Welcome back everybody to another Scantime training video. I know it's been a little while since our last video, but we've been absolutely manic at the training centre over the past couple of months, and we've been doing quite a bit of work behind the scenes developing something new which is to be released in the new year, so stay tuned for that one. What we're going to be able to look at today, guys, is tracing inside of our PLC, more so the Siemens S7-1200 PLC using TIA Portal. Now, tracing is a new tool that's available in a lot of newer PLCs today, whereas older PLCs didn't have this facility. Tracing is very similar to trends, where we can actually see signals and how they are reacting with inside of the process, but we can actually do this without using an HMI or SCADA system, as it's built into the actual PLC programming software. Now I'm going to show you how this works and how we can set up our own traces inside of our PLC to capture signaling inside of the process. Now before we get started, don't forget to hit the like button, comment below what you thought about this video, and hit that subscribe. Let's get into today's video. Okay, so I've got a project opened up in Siemens TIA Portal. Let's go to add new device and let's add in our S7-1200 PLC. Not all 1200 PLCs support this facility, so we're going to be using an S7-1214C, which does, and we're just going to add this. You also have to make sure the version's also correct to support this facility as well. I believe version 4s support this whilst version 3s don't. If I just go to now detect, going to locate our PLC, there it is there, click on this and bring the hardware into our software. Okay, great. So what we're going to do is we're going to go to our program blocks and I'm going to create a small test program. One of the great things about tracing inside of our PLC is we can detect fast signals and see how they work. If we're just staring at the ladder logic and we're trying to detect fast signals and seeing them turn on and turn off, we might never see the program react because they're too quick. If you use watch tables, same problem. You're just going to be looking at the signaling and you might not be able to see it turn on and turn off, but we can do with a trace. So what I'm going to do is I'm going to add a little program in here, which is simply going to be two input signals that is going to control a latch. And it will look like this. So we'll use the first signal, and this will be, let's say, M1.0. We'll use a second signal, we'll call this M2.0, and we'll turn on Q0.0, and we'll reset it with M3.0. Latch on Q0.0. Let's give this some signaling. So we'll rename this to signal 1. We'll rename this to signal 2, and we'll just call this our motor, for example, and we'll call this our reset. There we go. Now what I want to do is I want to toggle these bits inside of the PLC, but if I right click toggle and turn it on and then I right click toggle and turn it off, that's not going to be like a fast signal as such, because it's going to take me time to toggle it on and toggle it off. So what I'm going to do is I'm going to create another network and I'm going to put in our M1.0 here and I'm going to run it to a timer, TON, and we'll just add that into the PLC. We'll then give the PT a short time period, so we'll give it 100 milliseconds. So that's quite a short time period, quite fast. And when the time has finished, we'll then reset our M1.0, so I don't have to manually go in and reset it myself. So what will happen is when I toggle M1.0, this contact will turn on, it'll run this timer for 100 milliseconds and then trigger the reset, turning it back off again. So if we think about this signal, it's only going to turn on for 100 milliseconds and then turn back off. This will then latch on our motor. If we trigger signal 2, it'll turn on. When we turn it off, it'll also latch on our motor. But what we can now do is we can use tracing to detect when these signals turn on and show us on like a trend to understand how these signals are working. So let's go and have a look at traces. Now traces are on the left hand side here, and it's just a tool and it's just called traces. If we double click our traces, this is what we should get. Now I'm just going to minimize some of these windows so we can get a bit more of a better view. And this is our tracing, and like I say, it's very similar to a trend. So here we've got our graph, we've got our show trace data, and it's currently set to none because nothing's been set up, there's nothing there. And we've got our start and our stop record button, and we've got some other tools here where we can manipulate the actual trend itself. Now before we can actually get started, we need to go to our properties. And here is the property for the first trace that we're going to be using. If I just minimize our properties again and I just drag this bar up here and just click on it, there we go. There we go. You can see here we've got no traces actually configured. What I can do is I can add in a trace. I'll just call this trace 1. There we go. You'll see it's got like a red border around it. It's because nothing's been set up. If I click on trace 1, like so, and now I go to its properties, I can start adding in the signals for trace 1. So what I want to do is I want to add in a couple of signals. I want to add in our M1.0, which is our signal 1. I want to add in our M2.0, and then what I want to do is I want to add in our output Q0.0. We can then choose the color of these trends. We've got here red, we've got cyan and magenta. What I want to do is, because we've got a light background, we can change that. I want to choose dark colors though. So instead of cyan, we'll use just a dark blue, and instead of magenta, we'll use a pure green. So we've got some dark colors now that will reflect better on the white background for our trend. Recording conditions, if I go to sampling, you can see here it's going to sample with our main block, and that's our OB1, and it's going to record every one cycle of our main block. What this is going to do, it's going to record on every one PLC scan. Now this means that depending upon how fast your PLC is scanning, it's going to take a sample on every scan at every X amount of time. And it'll tell you here, recording duration is going to be 47,659 samples. So if we look at our recording duration, it's going to record 47,659 samples. And we've got it set here to use max recording duration, so that's as many samples as we can take. So again, let's just imagine our PLC scan time is 1 millisecond. This is going to take 47,000 milliseconds before the actual buffer is full and then stop. So that'll give us about 47 seconds of readings. This means that we can't use trends for long periods of time. We can't use our traces for long periods of time like we would do on an HMI or SCADA. With an HMI or SCADA, we can run these trends for days, weeks if we wanted to, and all this data will be tracked because it's storing the information inside of the PC, inside of the laptop, and with laptops and PCs, they have greater memory than a PLC does. Whilst this tracing here is being stored inside of the PLC, so we're limited to how many samples we can actually take inside of our process. So we wouldn't use this for long periods of times, just short periods of times. Let's imagine we've got an intermittent fault when we are starting up our process. This is where we could use traces because we can then select the signals that we believe are causing the problem at the start of the process. We can then start the process, wait until the problem occurs, and we can capture all of that on our trace. But what we wouldn't do is we wouldn't use this for an intermittent fault, which could last a period of hours, a period of days, a period of weeks before it occurs again, because we simply just wouldn't have the memory to be able to do so. So we've got to be very careful about how we're working with this. Now, some people might say, well, one scan sample rate is too quick. I don't need a one scan sample rate that often because that's going to take a sample every 1 milliseconds. So what you could do is you could say, okay, then we'll take a sample every 10 cycles of the PLC, so every 10 milliseconds. The greater the cycles, the smaller the sample rate is going to be, but the less accurate things are going to be. If you've got a fast signal which is turning on for 100 milliseconds like in our process and then turning back off again, if we set our sample rate to every 1000 cycles, which would be equivalent to every 1 second, our signal might turn on and then back off again during the 2 samples, and we'll never see that signal happen. So we've got to try and find a nice balance. Now I'm going to leave this to every 1 cycle. We don't want to run this trend for too long. So we're going to leave it for every 1 cycle. The trigger, it says there, trigger mode, record immediately. So when we tell it to record, it's going to start recording, but we can have this trigger on a tag. So if you had like your start push button or your stop push button or anything like that, you can say, right, trigger when we press the start push button, and then it will start recording that trend. We're just going to have it on record immediately. So that's now our trace setup, and you can create multiples of these. So you can create a second trace, a third trace, a fourth trace. You can give these names and then assign different signals to those names there. So what I'm going to do is I'm just going to go back to OB1. I'm going to download this program first of all and start the PLC. So this program is now inside of there. If I go back to my traces that I've got over here, so now that we're back with our traces, what we're going to do is we're going to go online. And it'll connect to our PLC. I'll then just minimize this window here. We can now transfer our trace to our PLC. So here you can see we've got a configure trace. Making sure that's selected, I can then use this button here to transfer this to the PLC. Now it's going to bring up a warning message. It's going to say, do you want to enable tracing? And the warning will say here, using tracing while the process is running may endanger the life or health of personnel or cause damage to the machine or the entire plant. So it's quite a serious warning here, and what this is talking about is because we're going to be installing this trace inside of the PLC and then running it, the PLC is then going to have to send all of this data to our trace. This can slow down the PLC scan. We might miss certain signals might not turn on, and like I say, it then could endanger personnel or damage equipment because we're losing signaling inside of the PLC. We should only be doing this for testing purposes. Again, if you're unsure, don't use this in actual practical purposes. We're just using it here on a test bench. So it also mentions there, note that enabling tracing may increase the cycle time of the PLC as it's adding to the overhead of the PLC. So I'm just going to say yes to that because, like I say, we're on just a test bench here. And we can see here that the status is currently inactive. Now, I'm just going to open up a watch table. I'm going to go to add new watch table. And I'm going to type in the signals that I want to trigger. So M1.0, M2.0, M3.0. These are my signal 1, signal 2 and signal 3. I'm just going to pop that out and resize it so I can see both windows here. There we go. Okay, I'm just going to type in for the modify signal on signal 2 a value of 1. And I'm going to go to our trace data here. I'm going to drop this down and select trace 1. And now it's going to be ready. Now we're going to get ready to start this trace. So what we're going to do is we're going to click on record, and then I'm going to activate signal 2. What we'll see is we'll see signal 2 turn on. Our output will then turn on as well. When I turn off signal 2, our output will remain on until we reset the actual latch. So let's record this trace. Let's go into our program here and let's modify the signal. So our latch should now turn on. And if I then send that back to 0, fire that into the PLC, it'll then turn off. And then if I set this to a logic 1, fire that into the PLC, that should then reset my latch. And there we go. And now what we're going to be seeing is this trace running in the background. And you can see here it's starting to take our samples and it's starting to create our trend here. And there we go. 16 seconds, 17 seconds, 18 seconds. And that's how much that trend actually had taken. So this tells me that my PLC scan time is a little bit quicker than 1 millisecond because it should have taken 47,000, I think it was, samples in that period, and it did that over 18 seconds. So we don't get much data here, but if we've got a fast signal, like I say, on the start of a process or at a certain part of the process, this is where we can use this. And we can see in our trend over here that our signal 1 had remained at a logic 0 the entire time, but our signal 2 had turned on at the same time as our output did. And then we can see our signal 2 turned off and our output remained on, and then later on we then reset the output, but we don't see that as it didn't track that. Okay, so that's pretty useful at that side there. So what happens if our quicker signal turns on? Because this was on for quite a long period of time. So what about our quicker signal of 100 milliseconds? Well, if I just delete that modified value, and set this guy to 1, and now if I then activate recording again, and I then just fire this signal into our PLC, there we go, you can see it turned on and then turned back off extremely quickly. And what I'll then do is I'll then reset our latch. Whoops, it triggered the second signal again, not too worried about that. There we go, let the trend tick away. You'll see it do a quick refresh of everything. And there we go. Brilliant, there we go. So we can actually see here that this signal 1 turned on a few times. That's because I left that true signal inside of my watch table. But there we go, we actually see exactly what triggered our output there, even though that signal was only on for 100 milliseconds, because the sample rate was quicker than that 100 millisecond signal. We can see here that our signal 1 had turned on briefly, very briefly, 100 milliseconds in time, and that is what turned on our output. We then triggered our reset, and that reset our output at the same time. It then triggered our signal 1 again, not too worried about that. And then when I turned off the reset, it then triggered our signal 1 again, which then latched on my output. So if I just go to our watch table here, I then just 0 that and just reset our latch. There we go. Just send that back to a false, and then just delete that. So there we go, we can actually detect really quick signaling. What about quicker signaling though? What if we go back to our main OB1 and we change this timer from 100 milliseconds to 10 milliseconds? Let's fire that into the PLC and let's see if it would detect that. It should do, because again, our sample rate is every one scan of the PLC. So the PLC is going to be scanning this program, executing that timer, so it should be able to detect this. There we go, it's inside of the PLC now. Let's go back to our trace. And let's go back to our watch table. Let's set that to a logic 1 so we can get ready to set it. And let's activate recording again. So here, let's just trigger our signal 1. We never saw that signal actually change state, but it did. If I then just delete that, reset the latch, there we go, and set this back to 0, there we go, and then just delete that, back to the beginning again. Now when we get ready to detect our trace, you can see there's the signal. It's a lot quicker now. You can't really see it turning on for a long period of time here, but again, even though that signal was only on for 10 milliseconds, we would have never been able to see that from the PLC program. You would have never been able to see that turn on, but we can capture it via this trace over here. So it's a really great way of actually detecting these. Now, like I say, you can actually manipulate this trend a little bit better so we can visualize signals quicker. If we want to, we can use this selection window, zoom selection, and we can highlight the window that we want to monitor. And there we go, it now zooms in on that, and we can see a little bit better of a signal, and we can zoom in further and further again, actually capture that signal. And there's that input 1 turning on for 10 milliseconds, and we can now see it over a larger scale. So if we have signals turning on for extremely brief periods of time, we can detect that with this trace. If we just went back to main OB1 here, and I just went to view the program, and I just toggle the signal from here, we never see it turn on. It just remains blue all the time. That's because the laptop isn't updating our program that quickly. So from here, we don't know which signal turned on, but with our trace, we can actually track that. And that's what's great about tracing. Like I say, if we need to just track something over a short period of time and see which signals are turning on and turning off, we can use traces for that. If we needed to track signals over long periods of times, we needed to trace this for a lot longer than just 18 seconds. We need to trace it for a few days. there's other instructions that we can use, and that's what we teach on our IMFFP training, the Industrial Maintenance and Fault Finding Pro, how we can locate intermittent faults over longer periods of time. If you've got an idea about how we could do that, write it down in the comments below and let us know about how you would do that to track a signal over a longer period of time to detect whether it is turning on or if it's another signal that's turning on. I hope you've enjoyed this little video about traces inside of our PLC. What we might do is we might have a look at traces inside of another PLC like our RSLogix 5000, because that's also got the capability of that, as well as our Omron CX Programmer too, so we can see how they work in those PLCs. Until next time, don't forget to hit the like button, leave a comment below, let me know how you would do this over a longer period of time, and don't forget to subscribe. I'll see you again next time. Have a good one.